Let's rock.
Cool. So I have some slides in the beginning. For those, if you don't know what I do, I make this magazine, Objective-C.io. This is like a sneak preview. There's 2 sneak previews today. This is the next issue, which is going to be released in a few days. And then this is the app I make, DexSet. This presentation was made with DexSet. But of course, there's no good presentation software. That's why we're going to do live coding. And this is a new app I'm working on. And if you don't believe in Swift, this is all written in Swift. And let's see if it works. It's just a quick screencast to give you an idea of the stuff we're doing. So it's an app where we have a lot of nice photos in there, and you can drag screenshots onto it of your app. So these are the photos, and you drag a screenshot, and it gets composed into the photos. And this is all pure in Swift, which has been both really nice and a bit horrible, but mostly really nice. I had a good time. So that's the new app I'm working on. And yeah, today I'm going to talk a little bit more about the functional side of Swift. So this is a book I wrote this summer with 2 friends, and it's called Functional Programming in Swift. And it's about how you can do functional programming in Swift, because it's this whole different technique, and I think it's very exciting. It's not a silver bullet at all. I see a lot of people who are like, oh, and then we get Swift, and then we can do all the functional stuff, and then they get really disappointed because it's not going to cure all their problems. And I think that's also the right way to look at it. It's a different way of doing things, not necessarily better, but for some problems it might be a lot better or a lot more interesting. So let's get started. This is the last slide I have. There are no more slides. Okay, so what we're going to do is we're going to create a new xcode project, a Mac project. And let's store it here and see if this works. We can turn off this thing, I think, and turn off this thing, and open the main.swift. Can you all read this in the back? Okay, cool. So let's run it and see if it works so far. Okay, we didn't do anything wrong yet. That's good. So what I want to do is I want to read some data from the network and parse it into JSON and then extract some information out of the JSON. It's very simple, right? But let's see how complicated we can make it. We're doing functional programming. It has to be complicated. So first, let's define a URL. So we're going to use NSURL, and then you need to pass in a string. So I made a small mirror of the GitHub API. So let's see, I think if this works. Now we have a URL, and we can try to fetch a string. So this is, of course, doing things in a non-async way. This is like fetching a string in a blocking way. You should never do this in production code, but for the demo, it makes things a little bit easier. So we pass in this URL, we pass in NSUTF string encoding, no error, and then we're going to print a string. So now we're going to get the first error of Swift. Build failed. What went wrong? So let's look at this. And it says value of optional type NSURL not unwrapped. This is horrible, right? Who here hates optionals? Yeah, I see some hands. Optionals are the worst, right? So what xcode says is, well, okay, you can. Did you mean to use an exclamation mark? So let's do that and run it. And now all of a sudden our code works. So I can make this a little bit bigger, and you can see that there's some JSON. Okay, so far so good. There's also this other endpoint, Zen, and it returns a Zen message. It's not JSON, but so you get a bit of a feeling of the API. So if we want to parse JSON, we have to first get some NS data. So this was just to show you what is in the endpoint. So instead of having an NS string, we have to have some NS data. So we're going to write a function because we do functional programming. So let's say we write a function getData, and it's going to return some NS data. And then the input of the getData is a URL. So let's say an NS URL. So how do we do this? Well, we say let data equals NS data, And then we do the same trick, contents of URL. So we pass in the URL, and we need to pass in data reading options, all zeros, and we need to pass in an error pointer. For first, we can pass in nil. And then we just return this data. And let's see what happens. I think Swift is going to complain once more. So it says, yeah, you need to unwrap this data. Well, we know that this is always going to work, right? So we just put in an exclamation mark. And now, instead of printing the string, we can say print line get data and pass in this my URL. And hopefully we get some data out. Yeah, that's nice. So we can get rid of this string. So far, so good. The next step is parsing the JSON out. So given some given some data, we're going to return some JSON. So let's do that. It's also a small, tiny little function. So it says given some NS data, I'm going to return you some JSON. And the JSON is going to be in dictionary format. So it's going to be, the keys are going to be strings, and the values are going to be any objects. So for that, we can use the standard API. So we can say NS JSON serialization, JSON object with data, and then we need to pass in the data. We also need to pass in some reading options. So we can say all zeros. And we need to pass in an error pointer. Well, we don't care about errors yet. And this is going to be an object. And then we're going to return this object. So let's see what happens now. We get another failure. Oh, I think it needs to be all zeros like this. Yeah. Please help me if you see me making any mistakes. So now it's complaining about, well, JSON serialization, JSON object with data is going to return an any object. And what we really want is this dictionary. So luckily, Swift has this thing to cast. Oh, I lost my mouse here. Oh, yeah, there it is. So we can say as string any object. And this is a forced cast. So now the compiler is giving a warning, but I think it's now happy. And we can use this function. We can say parse JSON and parse that data. All is fine. It's working. We get a dictionary out. Now I'm going to write a final function, and we're going to start refactoring and making things maybe nicer and maybe also more complicated. So the last function is to get this. If we scroll up all the way up, you can see here that there's this public repos key. And just for the sake of the demo, we're going to try to extract that integer out. So that's going to be called parse public repos. And we have this nice little function, which given, actually, let's make a type alias. So this, we keep typing this JSON dictionary all the time. So we're just going to call it JSON dict. And JSON dict equals. So that's a little bit easier on the eyes. JSON dict. So this parse public repos is going to take a JSON dict. And then it's going to return an integer. And we just look up the key in the dictionary and then force cast it to an integer. So we can say dict, what was it, public repos. Let me scroll up. Yeah, public repos as int. And we need to return that, of course. And now we can call this function parse public repos. And we get this nice function pipeline. So we get 45. Basically, we're done now. Except that we're not, because there are lots of problems with this code. So the first thing is the network could be down. So let's bring down the server and run it. Ow. So we get a hard crash. It's not even saying like, oh, something went wrong. Our app just crashed, and we definitely don't want that. So I'll bring the network back up because this is not good, right? Let's run it again. Okay, we get 45. The other thing that could happen is the JSON parsing could fail. So if I put in the Zen endpoint, it's not JSON. And we get a hard crash in parse JSON at a different point. That's also not good. there's one more possible place where we could crash. So if I put in Chris as the user, then we get a crash in parse public repos. So this is really bad. And this is why you should never use the as without a question mark, and why you should never use this exclamation mark, because even though you think this will almost always succeed, it might break, and then you get crashes at runtime. And crashes at runtime, you really don't want that. So what can we do? Well, we can first try to solve this parsing the public repos. We need to solve the 3 problems separately. So instead of an integer, we could return an optional integer. And optionals can either be nil or have a value. So, and luckily this fix is very easy. We can just say as question mark. And now hopefully it will work. So now we got nil as the result, but our program ended successfully. So we did not get a crash. This is really nice. This is the kind of behavior we want. So let's do the same for parsing the data. So instead of nsData, I'll make sure to first make it crash again. So hopefully now it'll crash. Yeah, we get a crash. Excellent. Instead of parsing the data, we instead of returning a JSON dictionary, we return an optional JSON dictionary. So here we can do the same trick. And let's try to run it. Oh no, we get an error. What's happening here? The compiler is complaining. Let me zoom into this error. It says, hey, it's not unwrapped. Did you mean to use exclamation mark or question mark? Well, let's do that. And run it. Now we still get a crash, but at a different point, because we are forcing this optional, which was really nil. This data could not be parsed. We're trying to force it into nsData, and the compiler will crash, or the program will crash. So in order to do this, we can extract some stuff into variables. And so we need to get this whole thing and put it into a variable. So let's say, let's JSON equals, oh, yeah. Remove this question mark. And now we can look at the type of JSON. So if you alt-click on a variable name, you can see the type. And we can see that it's an optional JSON dictionary. And what we want is a real JSON dictionary. So the trick to do this is to say if-let. And now if-let, the body of this if statement is only going to succeed if the JSON value was not nil. Otherwise, we can print something. We can say, oh, an error happened. So it says expected expression. Oh, yeah, there's a parentheses too many. So now we get an error, a program exits successfully, and if we actually have had JSON in there, so let's say users, we get a function. This is interesting. Oh yeah, we need to of course use the value. And we get optional 45. So you can see that this is different. So instead of nil, it's now an optional 45. It could have been nil. If we go back and change it to the JSON that does not have the number in it, we get nil. So that's good. It's a little bit better. Now the other thing is to parse the data. We want to have the same trick. So we use data question mark, and we can just remove this exclamation mark, run it, and this is how I always work, right? So I change some things around and change my types around, and then the compiler is going to say, hey, there are some problems. And this is a very powerful technique, so you can use the compiler to help you. And instead of like having this compiler that always warns you and forces you to do these optionals, you can let it help you to rewrite your code. So we need to do the same trick. We parse it, take this get data, and we say if let data equals, and then put some nice braces around it, indent it a little bit, and pass this data on. Build succeeded. And now if we shut down the server, it's hopefully going to work. Finish running. Oh yeah, we got no, because we're not doing anything, we need to put in an else and say error. So build succeeded. Right. So this is a little bit better. Our code doesn't crash anymore, but when we see then when the error path happened, and only if all the individual steps succeed, then the number gets printed. So that's a little bit better. What I don't like about this is that it's sort of hard to see what the error is. And depending on the app you're building, you might want to present this error to the user. So you might want to say to the user, hey, the network was down, or hey, I couldn't parse the JSON. It really depends on your users. I don't think you want to say, I couldn't parse the JSON, but this is something that would be really nice. So we can take a first step and just, instead of passing all this nil, we can pass in an error pointer. So you can do it like that. So you can say for error is of type NSError, NSError is an optional NSError. So it might be set, right? And then you can pass in a pointer to this error. And now what we can do is we can say, well, if we actually got an error, then we're going to at least print the localized description. This will help us during debugging. So now it says the file Objective-C.io couldn't be opened. That's a little bit better. And we can do the same for the JSON parsing. So let's say we do, it's exactly the same trick. So you say NSError. We can set it to nil maybe, and pass it in here. And error, and then we do the if let. This is getting a little bit repetitive, right? And we print the localized description. And now let's run it. Well, it still complains about the network. So let's bring the server back up. Now it parses, but if we put in something that is not JSON, like the Zen endpoint, it says the data couldn't be read because it isn't in the correct format. That's already much nicer. So finally, we can do the same trick for parsing the public repos. So we can if, for example, we can put this into a variable, let number, for example, return number, and if the error or if the number is nil, then we print couldn't parse number. And now if we change this endpoint back to Chris, then it says couldn't parse number. So this is very helpful during debugging, and we can at least see what is going wrong. It's better than these generic error messages. Except that we still cannot present this to the user. Let me get rid of these two lines. We don't really need this. In order to improve this, we need to make a new data type. And before we do that, I want to have a little bit of a look at optionals, what optionals really are. And it will help to understand how we can make this new data type. So here it says int question mark. So we can, for example, say let 5 has the type optional integer, and we can put 5 in there. And there's a lot of compiler magic going on under the hood. So what is really what's really happening here is it says sum 5. And the other thing is this question mark is really special. It's also some syntactic sugar. So what's really what the compiler sees is optional int. And the nice thing about writing it this way is that you can click through. That's the only advantage. So we can click through and look at optional. And here you can see what an optional really is. It has two cases. So it can either be none, which is the same as nil, or it can be some t. So if we, for example, try to make our own optional, let's see, for example, here in my optional, of course, it needs to be generic over the type, so that's how you say that. So there could be any t in there, and it can either be none or it can be some. And oh, I always forget that you shouldn't write the dot. So this is how you can define your own optional. The other thing that's really special here is this if let. So that's also some compiler magic. And what's going on beneath, under the hood of the if let is really a switch statement. So let's try to look at the switch statement. So I'm going to put this into another if let number, and put some braces around this. So now it only prints a number if there was really a number. Put it back to the working URL, and we get 45. So we can rewrite this if let statement, because that's the special thing, right? So what you can do is you can say switch. So I'm going to copy this and say switch parse public repos. And one of the cool things is that we now get auto-completion for the cases. So you can say, well, in the case of, at least we should get auto-completion. In the case of none, we want to print some error maybe. In the case of some, and we got a number, then we want to print this number. And let's see, this is how you can interpolate that number in there. Now I made some kind of mistake. Oh yeah. And now we can get rid of this if let. So it's really the same thing. So this if let is a switch statement. And the interesting thing is that we can define our own optionals. So if we scroll back up, one thing that we could do, which could be very interesting, is attach a message to this none. So instead of having nil or a value, we could say, well, this failed, and here's the error, or you get the value. And it would look something like this. So it would look something like NS error with a capital E. And now something is either a failure or it is a value. So how would that work? Well, for example, we could do this with the data. So instead of returning an optional data, we say my optional NS data. And now if we run it, it says, well, cannot convert the expressions type NS data. So now instead of returning the data, we need to say if let data equals, and this is optional data. I'm going to rename this a little bit. If this is if this was not nil, if there was a value there, then we're going to return some data. Otherwise, we're going to return the error. Like this. So we can remove this. We can run it. Build failed. And now it starts complaining below. Before we start finishing that, I want to rename things a little bit, because I'm calling this my optional, but there's really a better name. So we can call this result. And instead of calling it none, we can say error. So this is the error case. And instead of saying some, we can say success. So now it's a bit easier to understand what this does. So if you get something of result t, you know that it's going to be either an error or it's going to be success. Okay, so we need to rename this little function, and we need to change this to success and change this to error. And at least compiler is happy about this part. Now this if let is not going to work anymore, because if let only works on optionals. So we need to do a switch. So I'll do it just above here. Switch get data. And hopefully now we get, no, we still don't get auto-completion. We should. So in case of the error, we're just going to print it. In case of success, we can continue. So now we have some data, and we can continue our computation. So we can move this whole part in there. It's getting really complicated now, right? It's going to get more complicated. Build failed. Let's see what's wrong. Result T. This is very interesting. So it says that it cannot generate code for this result data type. And this is a current limitation in the Swift compiler. And in the beginning, the compiler would segfault when you would try to write this code. And at some point, I was always hoping that they would make this work. And then at some point in the release notes was like, oh yeah, the compiler doesn't segfault on these kind of things anymore. So it made me really happy. And then it turned out that instead of segfaulting, they made now a compiler error. And now is the only magical thing, the really magical thing that I have to do is, let's see if it autocompletes. Yeah. We need to wrap this value in a box. So the problem is that the compiler with this result data type, it doesn't really know what the size is going to be. So in the error case, it knows it's going to be this error, and then the NS error is an object. In the other case, in the success case, the T might be an integer, but it could also be an object, or it could be some kind of struct. So it cannot dynamically calculate the size. And the trick that we can do is wrap it in a box so that it's always going to be the same size. So let's see if we can make this work. Well, this error is gone, and now we need to box this data up. Build failed. And now we need to unbox it here again. So it gets really complicated, and it's gonna be worse. But at least our code is still working. If we now stop our server, we get this error. And the nice thing is that it now prints at the moment we want it to print, and not at the point where the error happened. So we have control over this printing. If you look now at get data, you see that there's no print line anymore. So we know what we want. We can decide what we want to do. We can print the error, or we can log it to our server, or whatever we want to do. Okay, so what we're going to do is we're going to also rewrite the parse JSON to a result, and we're also going to rewrite the parsing the integer to a result data type. So hopefully this is a little bit quicker. So this is going to be a result of JSON dict, and now of course the compiler is going to complain, and we can say, well, if let object, and I'm going to move this cast straight to after here. So we're going to do this in one step. So now we know that the JSON was parsed and it's a JSON dictionary. So we can return the success with the object. Otherwise, we're going to return a failure error with the error. Yes. The nice thing is, of course, that the question was, shouldn't you box it? The nice thing is that the compiler is complaining, but once we write box, the message will go away. And this is really like, it might seem like this boxing is very magical, but the compiler is there to help you. So we can run it, and we get an error at the bottom. So now we need to do the same thing and rewrite this if let to a switch. So we can switch here. In the end, the code will be very beautiful, hopefully. So we get the case of errors, and we print the error. We need to, of course, define this error. And we have the other case where it's success, which is what we want. And we get some JSON out. And then we can put this code in there. There's a lot of repetition here already. So let's see what the compiler is complaining about. We can run it. Oh, there is too many braces. That's one thing. String is not identical to any object. Oh yeah, we need to unbox it again. And build succeeded. So the last step is refactoring this parse public repos, and then we're going to make it more beautiful. So we do one more ugly step, and we're going to make it more beautiful. So now we say, if we can parse this number, so if let, then we're going to return success. That's the easy case. We need to box the number. If we cannot parse the number, we need an NS error. So we need to create our own error. So we can say let error is NS error. And we need to pass in a domain and a code. So let's say object.io, and then code is, I don't know, 42, yes. And an empty dictionary. And now we can return an error. So almost done. The compiler is happy about this part. We need to switch this, and we already rewrote the switch to, or the if let to a switch. So now we just need to say let error and print a localized description. Or we had success and we had the number. And let's see if this runs. Build succeeded. File object succeeded. Oh, couldn't be opened. Oh yeah, our server is still down. Number MCE.box. So we can unbox this. And now we have the same code, except it's way more complicated. We're not done yet. One of the things which I think is nicer about this code, if we now, so this function became really complicated, right? It was one line with just the exclamation marks, and now it's like, I don't know, 100 lines. The nice thing, what I really like about this, is this parse public repos, for example, is very self-contained. It says, if you give me a JSON dictionary, I will either give you an error or an integer. And it doesn't really know about anything else. The parsing the JSON is the same. If you give me some NS data, I will either give you an error or I will give you the data. And there's no print line in there, there's no logging, there's no nothing. And you can decide later on what you want to do with that. And it's the same here with the get data. So it says if you give me a URL, I will either give you an error or I will give you data. And I like that part. So now how can we make this simpler? So here it's a lot of the same stuff. So we do a switch, then we say case error, case success. Then we again have a switch, we have an error, or we have success. And this is very repetitive. So let's try to extract that in a function. So I don't know of a good name, maybe we can call it when. So when says, if you give me some kind of result of A, so either an error or data, and then if you give me a function that, given an A, returns a result of B, then I can give you a result of B. So we need to name these things. So let's say this is value, and this is function F. In functional programming, people like really, really short names. It's the opposite of Objective-C. I don't know if it's better. I'm not really sure about that. So how would we go about implementing this function? Oh, I forgot something. We need to declare A and B. This is how you declare generic parameters. How do we go about implementing this function? So there are only two values that we can really use. We can use value or we can use F. Well, in order to use F, we would need an A, but we don't really have an A. So by that logic, the only thing we can do is do something with value. So for example, we could switch on it. So we can say switch value, and now we have two cases. Whoa, we get autocompletion. Yeah. So we have the error case. And in that case, we still don't have a value of A. So the only thing we can do is return an error. So we return an error. We just return the same error. In case we had success, and we have this boxed thing, then now all of a sudden we can use this boxed value to call F. So we can say F box.unbox, and we need to return this. And we need to wrap it in success. So let's see. Yes, and box it. Something is wrong. I think, no, we just need to return F, sorry. This will happen automatically. Okay. So our function works. Now let's see if we can rewrite some of the code. Now hopefully things will start getting more beautiful and less ugly. And I have a magic trick for the end. So how would we use it? Well, we can say when get data. So get data returns a result of data. And then the other thing is we need to pass in a function. So you can define a function like this with the curly brace and you say data in. Now we can get rid of this error case. We can get rid of the success case. And we need to close the parentheses. And this is almost working. Let's see. Yes. Okay. I'm going to take a step back and solve things a little bit differently. So we're going to write a function first. We're doing functions. So we're going to write a function parse repos. No, get repos from URL. And it's going to take a URL and it's going to return some result of integer. I'm going to put the code we already had into a separate function. This will make it a little bit easier to refactor it later. So I'm going to take all of this code and put it in here. And I think I might be doing something wrong. Well, let's see. Okay. We can now rewrite our get data, I think. So we're going to do the same thing. We're going to say when get data, and then do this function data in, and remove these lines, and remove this, and close the parentheses, remove this one, and hopefully, if we now return, the compiler will be happy. Let's see. And this data does not have a member. Right, it's already unboxed, so we can also remove that unbox. And then here, we say, instead of printing, we need to return the error. Sorry for the slight confusion. And instead of, in a success case, we need to, well, actually, we can just get rid of this, and we can return this. So things are getting a little bit simpler. Now, this, oh God, I screwed up. This is interesting. Yeah, this is
curly brace is missing on line 74.
On line 74 is a curly brace missing. Yes. So there's this one. So now here we need to also return .error. And now the build is succeeded. So it might seem like magic, but this is really how I work with the compiler. I know it will warn me if I'm doing things wrong. And we can see if it still works. Get repos from URL, and then pass in my URL.
You're passing my URL to get data, but get repos URL.
Oh yeah, this needs to be URL. Thank you. And we need to put an exclamation mark here. Build succeeded. It's this enum value, and this is the result data type. So we have this function, and it's a little bit simpler. What we can also do is change this switch to a when. So here we say return, we say when, parse JSON, and then the second thing is going to be JSON in. So it's a very mechanical conversion process. And instead of the cases, we can get rid of this, we can get rid of this, we can get rid of this, and just close this parenthesis, and we need to not unbox. So the unboxing is also gone. Okay, this is already a little bit simpler. And you can see that we can really get rid of all of this duplication we had. If we look at this function, let's see, what does this function do? It says, well, if you give me JSON, I will call parse public repos with JSON. So it's sort of the same thing as saying just parse public repos. Parse public repos. So it's really the same thing, and let's see if it still works. seems to work. We can switch on this guy. Switch. Case error. We're going to print the error. And in the case of success, number, we're going to print the number. We can say success. Yeah. Success, MCE.box. So we need to unbox it. So it's still all working. And notice that this really big block of code we had, by writing this one when function, we made it very tiny. So now it's time for the magic part. And you might hate me for this. I really like this, but I just want to give a fair warning. I'm not sure if it's a good idea, but what we're going to do is we're going to create a custom operator. So we're just going to say infix operator, and let's call it something unpronounceable, when. And then you need to write these two magic words, associativity left. And then instead of when, we're just going to write this operator. Associativity. English is really hard for me. So now we can replace this and this, but with an operator you need to write them in an infix way and not as a function call. So what we can say is we can say get data URL and then parse the JSON and then parse the public repos. And hopefully this works. I need to somehow put this on a single line. And it works. So this is a bit weird, right? What happened here? We started with having this one nice pipeline with all the exclamation marks, and it was really completely, if there was any error at any point, then we would crash. And we refactored it to optionals, which was nice, but we didn't have error messages. And now we refactored it to this result. And if you look at the individual functions, they're still very simple. It says, like we went through before, given a JSON dict, I will either give you an integer or an error. And to hook up all these functions next to each other, we can just write it as if it was shell scripting, right? Like you just pipe them all into each other, and the compiler will do the magic for you. It will compose them. So it really, you can if you know what the operator does, this code is very readable. So it says, well, if you give me the data from this URL, then I will parse the JSON out of that, and then we'll parse the number out of that. So you can write these nice functional pipelines that do everything for you. You might think this is a bit crazy, but once you get used to it, it's a really nice way for solving these kinds of problems. And I use this a lot in my own code. And hopefully by the end of the month, we will also ship that. So yeah, that's really all I have to say, and I'm happy to take any questions. Thanks.
Thank you very much. It was wonderful watching you doing the refactoring and knowing the flow. So the first question is, isn't the operator overloading a little bit scary?
Yes.
Yes. Okay, so what's the next question?
So it's a really tough thing. So people ask this a lot, and it's a really good question. So if you think about it, it's really nice that we can write the operator, that we can write 5 plus 3. It would be a bit tedious to always write plus, P-L-U-S, and then in parentheses 5,3. So for some things, it's really nice to have operators. For a lot of things, like one of the scary things is if you look at a C++ library with lots of operators, this is super scary because you have no idea what's going on. The operator that I just showed, the function that we did, is actually, and I'm almost afraid to say the M word, but this was a monad. We just made a monad. And this is a really common operator in functional programming. So I think for very common things, it's nice to have a custom operator. but we should be very careful with introducing new operators. Yeah.
Okay, thank you.
I think one point that people often miss is the difference between overriding operators and adding operators. Like if you have a result and then suddenly you have result plus some other result, and that's where things get weird. Like suddenly plus means something different. And
Yes.
that's what people should not do.
Yeah, if you have an existing operator like plus, sometimes it makes sense to override this, but sometimes it can be very confusing. So we could have named this plus, and it would all work, but it's very confusing if you look at the code, what's happening there. But for strings and numbers, there's plus, and there it sort of makes sense because it sort of expects what you do. But yeah, it's a very good point.
Okay.
Hi, Chris. Thank you for the talk. One question: how would you add an additional parameter inside the pipeline of the functions? Because what I saw here is that you only take parameters for the first function in the pipeline, and then everything else in the pipeline is a pointer to a function, and
yes,
then you can
we can have a look at it if we can get the screen back on. I can show a little bit. So for example, let's say we want to parse, change this get data function. For example, we want to pass in these options. That would be something you would want to do, right? For example, so let's say options. Now the problem is if we define it as a parameter here, what's this called? NSJSON reading options. Sorry. What was the type again? Data reading options. So if we say options NS data reading options, then this is never going to compile because exactly like you say, the types don't match up. But here there's this other crazy concept called currying, and currying can do this for you. So what you would say is, well, get data is a function that, given some options, returns a new function. So it says it returns a function from NSURL to result. So this is the return value. It's sort of like a partial application, yeah. So and now you can say URL. Now you need to return a function in here. So you say URL in, and you wrap this whole thing, and hopefully the compiler will not complain about this part. And here we can use the options. So this is good. Now we get an error here because, yeah, the get data. This was the wrong example. So what you can do is you can apply this to the. You can pass in the options here. So let's say this is get data. Is get data, and you pass in the options, and then you use my get data, and you can use the same tricks for parsing the JSON. So you can sort of, instead of having a function that takes all the parameters at one time, it takes one parameter, and then it returns a function which takes another parameter and returns a function, and you can get really crazy with this.
That's a great thing.
I really like that you are trying to achieve the most beautiful code, but one thing that really it doesn't make it more readable is all that boxing dance. So is it just a current implementation detail of Swift language, or is it somehow connected to all the patterns that you saw?
I really hope it's a current implementation limitation, because they give this warning, and I mean, they know that we cannot really solve this. They know that they should fix this. I think it says unimplemented feature. So because they call it unimplemented feature, I assume they would implement it. And the people who are on the Swift team, a lot of them are very much, they want to write code like this. I know one or two people only online. But I've seen the code that they write, and they want to write some of the similar code. Maybe not as crazy, but I think they want this feature really badly themselves. But what I really like is that they are not implementing all these nice functional things, because there's a lot of nice functional things they could do, but they're trying to make the thing more stable, which is really needed. So I'm happy that they focus on that. First making like the source kit crashes go away, and once it's stable, they can add more nice features for me. But yeah.
Okay, the last question is from me. Are you hungry?
Always.
So it's time for lunch.
Tak,
Thank
tak,
you very
tak.
much.